AWS Lambda is a compute service which allows us to run code without provisioning or managing servers. I have talked about Lambda and the different integrations on this channel before. You can combine AWS Lambda with services like API Gateway or function URLs to build API endpoints for your application. But what if you are already building an application on ASP.NET Web API and want to use AWS Lambda? You might not want to go through all your work and convert your API endpoints to individual Lambda functions. But what if there is an easy way to host your ASP.NET Web API applications on Lambda Functions? In this video, I'll show you exactly how to do that. We will take a sample ASP.NET Web API application and host it on an AWS Lambda function. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Azure, AWS and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. If you're interested, you can check out the full series linked here or in the description below. Without much delay, let's get started hosting our web API on the Lambda function. I have Visual Studio open here, so let's scroll down and choose Create a New Project. Let's select ASP.NET Core Web API and let's click Next. Let's give this project a name. So let's call this as API on Lambda and let's choose the correct folder to save this in. And let's click Next. Let's leave the options as default. So this is currently running on .NET 6 and it's using controllers and not minimal APIs. So let's click Create. Now, even if you're using minimal APIs to build your API endpoints, the process is exactly the same. I will show you by adding a sample minimal API as well on this application. The application is created as expected and we have the program.cs and also the controller, which is the weather forecast controller. So we will work with this default controller for this example. So if you want, we can also come over to the program.cs and create a minimal API endpoint in here. So let's add an extra line. So let's say app.mapGet. So this is going to be a get method. We can specify the route here. So let's say /users and let's specify hello world inside this. So let's simply specify a delegate handler and return hello user. Now this endpoint is going to get hit if you navigate to /users. So let's run this to see this in action. The application is running and by default it launches the Swagger UI because that is configured on the template. Now you can see we have the /users endpoint and also the /weather forecast. Now if I was to invoke this, you can see it's going to return the hello user in this response. Similarly, the weather forecast is also going to return us some data. Now that we have our web API up and running, let's see how we can deploy this into an AWS Lambda function. So let's close this and let's stop this application. To host the ASP.NET Web API on the Lambda functions, we need to add a NuGet package. So we have to add the amazon.lambda.asp.NET Core server.hosting NuGet package. Once added, all we need to do is make a call to the add AWS Lambda hosting method. You need to specify the event source for this Lambda function. We will see how to do this a moment later. Now, with the add Lambda hosting added, when you run the project locally, it does nothing. When running on Lambda function, the NuGet package swaps out the Kestrel server with the amazon.lambda.asp.NET Core server. We will see this once we add the NuGet package and enable our application for Lambda hosting. So let's navigate back to our application and let's install this NuGet package. So let's copy that, come back to our application, right click and manage NuGet packages. Let's search for the new NuGet package. So let's search the package name and we can add this into our application. So let's accept. The package is successfully installed. So let's navigate back to program.cs. If you navigate to the package NuGet page, you can see all you need to specify is builder.services.add Lambda hosting. In this case, it also passes an argument which says its HTTP API is the source for this hosting. So let's do the same on our application. So let's say builder.services.add AWS Lambda hosting, and let's specify the Lambda event source. This takes different values: application load balancer, HTTP API, and REST API. For now, let's choose HTTP API. Let's collapse this. Let's navigate into this method to see the underlying definition. Now this uses the environment variable AWS Lambda function name, which is by default present on AWS Lambda environments. Now, if this environment variable does not exist, which is the case in our local environments, it returns back the service collection as is. However, if this is running on the Lambda environment, it uses the Lambda event source to specify a different server. So based on the event source, it creates these three different types of servers to support the different endpoints. This is because the REST, HTTP APIs, and the load balancer requests have different payload formats. So based on the type that we specify, it creates the appropriate server to host our application. Now in our case, since we have specified HTTP API, it's going to use the API gateway HTTP API v2 Lambda runtime support server. We will also see an example where we use the REST API. So once it has the server type identified, it's going to ensure this server is registered in the service collection. So if we navigate further into this method, you can see all it does is swap out the Kestrel server and add in the server type that we have added. This means the application will be using the specific type of server when hosted on Lambda Functions instead of the default Kestrel server. So let's run this again locally to make sure everything is working as expected. You can see the Swagger UI and the two methods still existing. So this is by default still using the Kestrel server. So let's close this and deploy our application into AWS Lambda Functions. Now if you're familiar with building Lambda Functions, I have shown you before by right-clicking we can deploy the Lambda function. However, on this project type, we do not have publish to Lambda function as an option. I will show you later in this video how to get that. But for now, we will be using the .NET Core Global tools so that we can deploy it from the console. So let's navigate to Windows Terminal and to the appropriate folder that this application is stored under. Now, once we are here, since I have already installed the tools, so I can use .NET tool list-global to list all the tools that's already installed on my machine. Now you can see here, I already have the Amazon.Lambda tools. Now if you don't have this already installed, you can use the .NET tool install -g and specify Amazon.Lambda.tools. This will install this onto your computer. Now once installed, you can specify the .NET Lambda deploy function to deploy this Lambda function. Now this is going to go through a series of questions before we deploy this. So it requests the runtime for which we can specify .NET 6 because that is the version our application is built on. It is going to package our Lambda function. Let's specify a function name. So let's specify API-on Lambda as the function name. It requests to specify an IAM role. So let's specify 10 to create a new IAM role. So let's specify API on Lambda role. We can select an IAM policy to attach. So let's specify the AWS Lambda basic execution role. So let's select 6 in this case. Now this creates the new IAM role for this Lambda function. Let's specify the memory size. So let's specify 256 MB in this case. Let's specify 30 seconds as the timeout. And now we need to specify the Lambda function handler. This is the entry point for this Lambda function. When hosting web APIs on Lambda functions, we need to specify the namespace name as the handler. So let's navigate back to our application. And if you look at the weather forecast controller, you can see the namespace name is API on Lambda. So let's copy this, come back and use that as the handler. So let's select enter. And this is going to create this Lambda function. So we have the Lambda function successfully created. If we navigate to my AWS console under Lambda, we can see this new function. So this is named API on Lambda. So let's navigate further into that. And you can see the Lambda function is successfully set up. You can also see the handler is specified as API on Lambda. Now to invoke this Lambda function over HTTP, I showed you in a previous video to enable function URLs. Now if you're new to function URLs, I highly recommend checking out that video to understand more about it. To enable the function URL, let's navigate to configuration and navigate to function URL. Let's create a function URL and specify the auth type as none. I have also shown you how to enable the auth type AWS IAM to secure this API endpoints. You can check out that video, which will also be linked here and in the descriptions below. For now, let's choose none and let's click save. This creates a new URL endpoint to invoke this Lambda function. Now the request model for the function URLs is very similar to API Gateway HTTP APIs, because of which the option that we have given here when enabling the Lambda hosting to use the event source as HTTP API is going to work for this as well. So let's navigate back and navigate to this function URL. Now right now it returns a 404 error because there is nothing on this endpoint. Now if I navigate to /users, you can see this is returning the hello user as expected. Similarly, we can also navigate to weather forecast to get the weather forecast data back, which is returning it in JSON format. Now the Swagger UI is currently not enabled because if we come back to the application, you can see this is enabled only if the environment is development. Now in a previous video on environments, I have shown you how to enable the development environment. So we need to specify the ASP.NET Core _ environment variable where the application is hosted. So let's navigate back to our Lambda function and let's navigate to the environment variables and add a new environment variable. So let's specify add and let's paste in the environment variable name, which is ASP NET Core _ environment. We can specify this value as development and click save. Now once this is saved, if you navigate back to the API function URL and let's navigate to swagger/index.html, we can see the Swagger endpoint in here as well. Now you can see the two endpoints, which is /users and /weather forecast. Now we have successfully deployed and hosted an ASP.NET Core application on Lambda Functions. If you want to make the deployment easier and have the right-click deploy option from Visual Studio, all you need to do is navigate back to the project. Let's open the Solution Explorer and let's edit this CS_proj file. So let's right-click on it and say edit project file. Now we need to add a new property. So let's specify the AWS project type property and let's specify that as Lambda. Now this is the property that enables the publish to Lambda function inside the right click on the project. So let's save this and let's navigate back to the project and you can see here we have publish to AWS Lambda. Now if I was to select that, we get the similar pop-up as we get when we were to deploy Lambda functions. Now in this case, let's specify a new name. So let's say API on Lambda and let's say -vs to indicate this is published from Visual Studio. Now we have the handler name as API on Lambda, which is the namespace of this application. So let's click next and let's select a new role. So let's specify the basic Lambda execution role and let's select upload. Now this is going to create and upload a new Lambda function. So by just adding that property on the CS_proj file, we are able to right click and publish from Visual Studio. The Lambda function is successfully deployed, and if we open the Solution Explorer, you can also see that it has automatically added the AWS Lambda tools defaults.json. Now if you navigate into that, it has all the information about our Lambda function, so that the next time we click publish, it is going to use the names from this file. So you can see the function name is automatically populated in this case. So let's navigate back to the console and let's see our new deployed Lambda function. So let's refresh this and here we have the new Lambda function. So let's navigate to that. Let's go to configuration, enable functions URL. So let's select none and let's select save. Now for this Lambda function, let's expose this using the API gateway instead of the function URL. So let's navigate to the AWS console in a different window, and let's navigate to API Gateway. Here we can create a new API Gateway endpoint. So let's use HTTP API endpoint since the current hosting is supporting the HTTP API. So let's navigate back. So let's click Build to create a new HTTP API. Let's add the integration. So in this case, we know this is a Lambda integration, and let's select the Lambda function. In this case, we have the API on Lambda-VS. You can see here, this version is also 2.0, which is the payload format for this integration. Now this is exactly the same that we used when we specified in program.cs as the HTTP API. If we navigate further into that, you can see the server that was used was also API v2. So if we come back, let's specify a API name. So let's specify API on Lambda-VS, and let's click Next. Let's specify the resource path. Now in this case, we want to proxy through all the requests onto our ASP.NET Web API. So let's specify /proxy plus, which is a way to specify all the paths to map to this integration. So let's click Next once we have specified that, and let's click Next with the default stage and click Create. Now if you're completely new to building HTTP API in the API Gateway, I highly recommend checking out my video, which will be linked here and in the descriptions below. Now once we have this set up, this will be automatically deployed. So let's navigate to this URL where the API is currently hosted, and let's navigate to /users. Now you can see the hello user returning as expected. Now if we navigate to the weather forecast, we also get back the JSON information. Now if you want to enable the Swagger UI, as before, let's navigate back to the Lambda function. Under configuration, go to environment variables and click edit to add a new environment variable. Let's add the same environment variable, which is the ASP.NET Core environment, and let's specify it as development, and let's click save. Now once added, if we come back and navigate to swagger/index.html, we will also be able to invoke the Swagger UI on this new endpoint. Now we have successfully set up the Lambda integration with an API Gateway HTTP API. Now similarly, if you want to do this on a REST API, we will have to update our Lambda function hosting code. So if we come back into program.cs and update this as a REST API, now instead of using the HTTP API v2 server, this will be using the API Gateway REST API Lambda Runtime Support Server. So let's build this and let's deploy this onto a different Lambda function. So let's right click and say publish to AWS Lambda, and let's specify a new name. In this, let's append -rest and let's click Next. Now this is going to create a new Lambda function inside our AWS account. Let's also specify the IAM role. So in this case, let's give the basic execution role and click upload. Now this is going to package our Lambda function and deploy this into our environment. The Lambda function is successfully deployed. So let's navigate back to our account. Under functions, let's refresh, and we have the new Lambda function. Let's navigate into configuration. Under environment variables, we already have the environment variable specified. This is because if you navigate to the AWS Lambda defaults, you can see that it specifies the environment variables and has the value already in there. So let's come back to the API gateways and let's create a new API gateway. In this case, we will choose the REST API. So let's click build, which creates a new REST API. Let's specify a name. So let's specify API on Lambda-VS-REST and click create API. Now this creates a new REST-based API endpoint in API Gateway. Now under resources, let's create a new resource and let's specify this as a proxy resource. Now as before, this will also map all the requests onto the Lambda function. So let's click create resource and let's create a new integration. In this case, this is a Lambda function proxy. So let's select the Lambda function. So let's specify the API on Lambda-VS-REST Lambda function and click save. Now this prompts to give the permission for this API gateway to invoke the Lambda function. Let's click OK, and the permission will be added automatically. Once we have set up this integration, we need to deploy this API. So let's click deploy, create a new stage. Let's give this as test and select deploy. Now, if you're new to building REST APIs in API Gateway, I highly recommend checking my video, which walks through all these steps in detail. It will be linked here and in the descriptions below. Now, once this is deployed, let's navigate to the URL and let's navigate to /user endpoint. So let's specify /users, and as before, we get back the text hello user. We can also navigate to /weather forecast, which is going to return the weather forecast information. Since we've already added the environment variable, if we navigate to swagger/index.html, this is also going to show you the Swagger UI. Now we have successfully integrated the ASP.NET Web API from a REST-based API Gateway application as well. I hope this helps you to understand how to host an ASP.NET Web API application on an AWS Lambda function. We learned how to set up the Lambda integration hosting and define the different sources. We also learned how to expose these APIs using function URL and using HTTP and REST API endpoints in API Gateway. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, make sure to hit that subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.